after the end of the lecture. So there we are. That streamed really quickly. I've been having some performance issues. So one thing I've just tried on this stream today is I've pushed the frames per second down. So I may look a little clunky compared with last time. But I want to see that I've been getting a bit annoyed with my pen not keeping up with what I'm writing, and I want to see if that's going to fix the issue. So yes, we are being recorded. And yeah, I learned all sorts of stuff about, I think I said at the beginning of semester, for criminal actions, Connecticut is just a one-party consent state, meaning that only one person involved in the transaction needs to know that it's being recorded. But for a lot of civil stuff, torts and things like that, it's two-party consent. So here we are. Not much time to go. I really don't have much more to talk about. I have I better start my computer up. There we go. My laptop with Quartus and everything on it. I want to spend a lot of today, if I can, talking to individuals. We don't have many people here, so that should be okay. And we'll see where we are. One thing so that's where we are. I do want to review. I talked about how to form the grade last week, and I've just put in an extra slide after this one. This is the slide I showed you last week about how we get to the end of semester, and this is, if you like, an update on or a more formalized way of presenting the way I described. I'll be altering it a little bit based on last week's lecture, right? I gather people are not happy about doing the project, so let's just do some drawing and check out, see if it works. Right, so the syllabus has that weighting. Yeah?
Sorry, are you supposed to be showing something on the screen right now?
I am. I believe I'm showing something on the screen. Can anybody see what I'm showing on the screen?
I mean, there's nothing live on Discord. Maybe I have to restart it.
Oh, really? It's a little live tab beside my name where I'm seeing it. Let me just... can anybody else not see me? Can anybody see me? Nobody's listening.
I have no clue.
I can see you.
For me.
Yeah? You can see me?
Yep.
Yeah.
Okay. So, I don't know what that means. Was it Adonica who couldn't see me? Is that right? Maybe try the YouTube link. Let me see if I can. Normally it emails me the link, but it hasn't done that just yet. Okay. I if you want to follow along, basically I'm looking at the slide called Updates to Grading discussed last week, and I'm just pointing out that the second column is the weighting that the syllabus says, where we've got 30% for labs, 20% for project, 10% for the game, 10% for midterm, and 30% for the final. And the first option I suggested is that we don't count the project at all, and we move, and this is the option A column, we move 10% onto the labs and 10% onto the game. And then I know there are some groups who are pretty far along in terms of all the labs, and I'm going to give those groups the option of doing a project, and if they do that project, and it has to be a reasonably complicated one, not too complicated, but reasonably complicated, I'm gonna say that that's worth a potential bonus of 20%. So that's column A plus, and the total for that column is potentially 120% out of 100. If you got 100% on everything, 100% on labs, 100% on the project, 100% on the game, 100% on the midterm, 100% on the final. The other option, option B, is there are some people who don't have access to the game, and I'm saying that that just weights everything else appropriately. So that means the labs are now worth 33%, project 22, midterm 11, and the final 33. Okay. Then option C is if the project is not done, then we just weight the labs, the midterm, and the final, and that gives us that. And then option C plus is the same as option C, but now if somebody wants to do if somebody in taking option C wants to do the project, then there's the potential to get up to 120% on the for the final grade. And they're basically the options that I laid out last week, and I'm perfectly happy to calculate all of them and give you the best, right? So if you decide, basically you don't have to decide. I will give you the top level of all of those. I will display all of those in Blackboard so you can see what I'm doing, just in case I don't set up Blackboard appropriately. But we'll do it that way. Okay. And the rest of these slides are basically the same as last week. Because what I want to do today is I want to go talk to everyone and see see how we're going. So let me see if I can do a class bingo. Before I do that, does anybody have any questions about what I just talked about? Right, particularly this grades.
I'm having a bit of technical difficulty, so I missed most of it.
Okay. So Adonica, I talk to you a fair bit anyway, so if you have any questions, feel free to either ask now or ping me later on. That's okay. The fundamental thing is there's several different ways I could calculate your grade. I'm going to calculate all of them, or at least I'm going to get Blackboard to do it for me, and I'll give you the best out of all of those possible options. Okay, so let's do the bingo thing. And what I'm going to do, what I want you to tell me is where you are in terms, you or your group are in terms of the project or the lab 6, 7 and 8. All right, lab 6 I think is the individual one, and lab 7 and 8 are the group ones. So let's go with bingo, and let's go with Jordan. Jordan, how is your group going, or how are you going personally with labs 6, 7 and 8?
I have to pull them up. It might take a second.
That's okay. So let me just get, we can wait.
So I know lab, what is it, lab 6, I know I'm done with already.
Yeah, let me just pull them up. Yeah, you've already submitted lab 6, and it looks like there's some
and I think lab 7 we started working on, and I don't think we started lab 8 yet. I don't believe we started lab 8. I think we were gonna plan to if we finish lab 7 today, I think we're gonna start working on 8.
Okay, so just to remind me as much as anybody else what lab 7 is, right? So lab 7 is the up-down counter, and the idea is that you want to well, there's two things to it. There's the up-down counter, so an 8-bit counter that counts up and down, and then the other piece is you want to be able to show that it's an up-down counter by changing the LEDs on the board. The trouble with that is the clock on the board is a 50 megahertz clock, and even at the most significant bit, right, it's going to be changing at 50 megahertz divided by 256, which I can't do in my head. What is it? It's 50, 123 on 256. So it's going to be changing at 195 kilohertz or so. And you can't see that. So the LEDs, if you put the 4 most significant bits of the counter out, you couldn't see them changing because they'd be changing so quickly. The LEDs may possibly look a little different in brightness, maybe, but I suspect you wouldn't be able to tell. So what I'm asking you to do is to divide the clock rate down so that the clock rate is effectively 10 hertz rather than 50 megahertz. And we looked at the PLLs, phase lock loop setups in Quartus to try and do that, and we can't. The PLLs only allow you to divide down to the order of tens of kilohertz, I think. So you're going to have to also write a divider to get down to 10 hertz, or use the that modulo 50 million or a variant of that modulo 50 million counter that we did using the LM, was it LMC, was that it? Module counter from within quarters, the configurable up-down count. Okay, so I suggest Jordan, you and your group get cracking on Lab 7. I'll be around online. What I'm doing is I'm just going to take a note of what everybody tells me briefly, and there's I've added a column to Blackboard just so that I can keep track of, so it's Jordan, let's just, sorry, I need to reset this.
And then the only other thing is I believe I've made some progress in the game.
Oh, you have? Oh, good. Yeah, so that would be good. One thing I'm going to do at the end of semester is I do want you to do a bit of a reflection on the game in terms of whether you think it actually helps or not as far as understanding the course content. The guy who wrote the game was kind enough to give me all those keys for free, provided I gave him some feedback from the students. So I would like you to do that as a reflection. And it'll only be a paragraph or two that I'll just get you to type straight into Blackboard, if that's okay.
Yeah, that's not a problem.
Okay. Okay, so so I'm just going to type that into that 1114 column that's in Blackboard. Now you should be able to see it. Okay, thanks, Jordan. Let me bingo somebody else. Javier, how are you going?
I am finishing up Lab 6 today. I have the code all set. You and I talked about it. Thank you very much, by the way.
It's okay.
And then my group and I, we're going to continue to work on Lab 7 and 8 today. And then we do have a project in mind, and we do have all the hardware for it. So we're thinking of doing the ultrasonic sensor display.
Oh, cool. Yeah.
So she's going to tell us the distance approximately from the or an object is approximately to an ultrasonic sensor.
Cool. That will be interesting. So if you if you need any help, book a general consultation with me, and we can talk about how that might hang together. But
cool.
Yeah, that's...
Will do. And then the game, I am currently, I think I have 4 out of 6 4 out of 7 achievements. But yeah, it's a slow crawl.
Okay. Yeah, I mean, I actually haven't finished the game myself yet, so I should get back onto that. I think I left it. I got to the first part of the CPU, but I haven't finished it off. I keep... Okay, thanks, Javier. Let's bingo somebody else. Abraham, how are you going? Are you up to speed? No response? You're currently muted. No? Okay. I'll do that. Let's move on to somebody else. Amaziah, how are you going? How are you and your team going?
I still have to finish lab 6 and get ready to start the game.
Okay. Okay. Yeah, the game is a little bit time consuming. It's not too bad, and I actually found it more fun than driving quarters, to be quite frank. Yeah, you will need a bit of time to get most of the way through it. But it's basically a simplified VHDL or Verilog for that matter. But it does guide you quite a bit, and I found it quite useful just to understand how some of the things we're doing in quarters hang together. Okay, thanks, Amaziah. Let me... Jacob, how are you going? No response? So my wife tells me my dog was just barking there because there's a hawk in the tree outside her window. And, she's not very fond of raptors for some reason.
The dog or the wife?
The dog. My wife loves raptors. It's just the dog gets all uptight, and the hackles rise, and the barking starts.
Raptors can eat the dogs.
Yeah.
Like, we have many eagles around, and I've seen one of them swoop at my dog before.
Oh yeah, they'll certainly swoop. In fact, my dog wasn't a raptor; it was a crow. There was a baby crow with a couple of parents out on the back lawn a while ago now, over the summer, and the dog got it. I didn't see them, and the dog went out, and the baby crow just didn't take off, and the dog got the baby crow. I don't know whether she got it in her mouth or she just flipped it up in the air with her nose, and the baby crow got away, and the dog, it seemed okay, it flew away. But for the next couple of weeks, every time we went out, the dog was dive bombed by a couple of angry crows, assuming it was the parents of the baby crow. Okay, nothing from Jacob. Let me move on.
I didn't realize that crows are so vengeful like that.
Oh, crows are very intelligent creatures, and they certainly remembered, certainly for a couple of weeks afterwards. So it was kind of interesting. Matt, how are you going?
I'm working on labs. I gotta get a good time to work on 7 lab partner.
Yep. Okay, and have you tried to get the game going?
I've looked at it. Haven't tried it yet, but I plan on getting it done.
Okay. Okay, that's good. Okay, thanks, Matt. Let's move on. Kyle Fields, any thoughts? How are you going?
Okay, cool. I'm working on Lab 6. I believe I'm almost done with it. I'm gonna finish it today. I think I still need the key for the game.
Oh, yeah.
I think I forgot to email you about that. Sorry.
No key. Let me let me see if I can get you a key.
Awesome. Thank you.
That would be good. Yeah, sorry, I dropped the ball on that one too. And I think I owe 2 other people, Yasmin and maybe Danny, an attempt to do that, and I haven't done it. I will try and do that before next week, so you can play it over Thanksgiving break. How about that? Maybe not.
But yeah, I do intend to finish the game.
Okay.
And I think Lab 7, so this week is Lab 6, and then at the beginning of next week I'll work out with my lab group for the other labs.
Okay. Yeah, just make sure you leave yourself enough time. Lab 8 is a little complicated. In fact,
okay.
Yeah, but yeah, just make sure you leave yourself enough time. I was really happy with my progress on that. Actually, I was fiddling with it during the week. Let me see if I can figure out how to talk to my other laptop. There we go. So you should maybe be able to see that. Let's just make it a little bigger. I wish it kept the right. So you probably can't see it, but there's the right. There's the ball counter. There's the strike counter. And what I've done now, the thing I've added to it is the flashing the lights. Right, these are the LEDs down here, and if I get a strike, the LEDs flash 3 times, and if I get a walk, I just get 2 flashes. I don't know whether that's coming across in the video, but I flash all of the LEDs 3 times if it's a strikeout, and 2 times if it's a walk, which is kind of funky, I think. I'll start that up, and I'll show you some of the detail of how that's happening, because I think it's instructive. Okay, thanks, Kyle. Let me bingo somebody else. Stephen, how are you going? Stephen Homza, you there? Started the game. Okay. Thank you. Very good. Let me just okay, let me ping somebody else. Hey, I know where I am. Quentin, how are you going? You, I think I saw a submission from your, from Lab 7, so I haven't looked at that yet.
Yeah, that's so I have to just write up the lab for 6 today, and then sometime, hopefully by next week, me and Yasmin could start working on lab 8, and I'm currently working on the game as well.
Okay, thank you. Okay, that's good. And was Discord gone? So does Zach, how are you going? How's your team going?
I think we're doing good. We haven't started on Lab 7 yet. Still working on Lab 6. And yeah, I think that's it.
Okay, that sounds good. Just try and get it done before the end of semester schmozzle happens. Oh, and did you say about the game? Have you started the game? Are you looking at?
No.
No?
Not yet.
Okay. Okay. Thank you. And there was no one. I think I missed. So I have to go back to. We got Jacob before. Jacob, you want to give a response now? No? Okay. And I know where I am. We did Matt before. Celine, how are you going? I don't think we've talked to you today.
I'm going well. I just had to complete the write-up for 6 and then start with my group on 7, and then probably going to start the game just to get a little hang of it this week.
Okay. That sounds good. Thank you, Celine. Let me, and we talked to Zach before, that's okay. We talked to Jordan before. We talked to Quentin before. We talked to Harvey before. We talked to Messiah. Didn't get a response from Abraham. Abraham, how are you going with the labs?
I'm trying to finish up Lab 6 and move on and play the game as well.
Okay. Thanks, Abraham. Okay, let's see if I talked to Kyle before. Talked to Stephen before. Nazmeen, how are you going?
For Lab 6, I'm still working on it. I'm working, well, my lab partners with Adonica and Javier, so we're going to work on Lab 7 and 8 today, or at least start Lab 7.
Mm-hmm.
And then I'll probably plan to do the game during break.
Okay. Thanks, Nazmeen. Okay, let's And for some reason, I don't think I've talked to Kyle Bechtold, and it's not picking you up. So, yeah, you're invisible to the bot for some reason. I'd love to know how you do that. So how are you going, Kyle? And there's Yasmin and Anthony. Why is the bot? Oh, There's lots of people here who the bot isn't picking out. Oh, you almost.
Is there any way that it's just not updating the list when new people come in?
Yeah, that might be it, but I'm wondering why that would be. You would think. I think it's coded to get the new list each time, so that might be a bug in the bot. So I'll harass Professor Broderick about that. Even though I think I helped write it. So okay, so thanks, Kyle. I will update your status. Almost done with the game. That is very cool. I should. I think that tells me that I need to get a wriggle on with it, so I can actually see what it looks like at the end. Sorry. Working 6 and need to make more time 7. Yep. Oh really? What was the frustration, Anthony, with the game? I know it sort of does take control of the screen, but and it may not necessarily be clear what the navigation keys are. Okay. If you want, feel free to book a slot with me. In fact, I might see if I can start the game up later during this session, just so you can see where I am with it. And but I haven't played it for quite a while, so let me just finish updating Kyle's. Status. And sorry, what was that, Nasmin?
I was gonna ask, when will the final be released?
So I don't want to make too many promises, but I'm going to have basically the week of Thanksgiving. I don't have any teaching at Fairfield that week, and I need to write I need to write 2 finals for there and the final for 466. So I'm aiming to get everything written that week. So hopefully after Thanksgiving, I won't inflict it upon you before Thanksgiving, but after Thanksgiving I'll release the final. So you should have it minimum of 2 weeks before a minimum of 2 weeks before the bookings start, in order to do that, to have a look at the final. Does that answer the question?
Yep, it does. Thank you.
You're welcome. Yeah, so Jordan, if that's the case, I am perfectly happy to spend some time either during class sessions, now that I think I've covered everything I want to cover in VHDL. So if you have questions about the game, it is a formal part of the assessment if you want it to be. So I'm perfectly happy to talk about the game and solutions that I've come up with so far to the the game problem. Okay, that's all right. Sometimes that's not a bad way to go. I know when writing software, sometimes the first attempt at getting the software written just doesn't work as well, and you're better off just nuking it from orbit and starting it again. Although there's a guy called is it Frank Brooks, who wrote a series of essays that were put together into a book called The Mythical Man Month, and he wrote a lot of the early 70s IBM, or at least he and the team he managed wrote a lot of the early IBM mainframe software, and even today people quote stuff out of his book. The two main points that I can remember off the top of my head, one of them is the phrase "there is no silver bullet." Frank Brooks came up with that, right? There is no silver bullet, meaning there is no single action you can take to fix a complicated problem. You can take an action to try and mitigate part of the problem, and you certainly should do that, but there's nothing that's just going to completely wipe out the problem. And then the other one he came up with is, if you have a project that is late, then adding resources to that project will make it later. Which sounds counterintuitive when you first hear it, but the issue is the people who are already working on the project know it intimately. The people you add to the project know nothing about it. So that means when you add people to the project, the people already working on the project have to ask questions of the people who were working on it, and that stops the people who were working on it from working on the project. They've got to answer questions. So all of a sudden your velocity or your progress stalls. Hopefully the new people get up to speed quickly, but it's generally not as quickly as possible. Okay, so Anthony, I'll spend a bit of time. I just want to put in that you've there we go, working game. Okay, so yeah, I'm wondering what I should do next. I'm thinking maybe I should see if I can start up the game, and my only problem with that is I don't know which screen it's going to start me up on. So let me see if I can start the game up. Maybe figure out where it's gone.
If you have your Discord connected to your Steam account, then it should just automatically link.
Okay. Yeah, see, it's got the wrong screen. I don't know if you can hear that starting up.
We cannot.
Yeah, it's let me see if I can do this. I'll swap over which screen I'm broadcasting in Streamlabs and see what happens. Ooh, that says second screen. properties. And I'll go back to screen 0. Okay, so now we're getting the nice thing there. And let me see if I can start up again. So is that showing up at all?
Yes.
Yeah. Okay. So here's the game, and right, I'm just scrolling down. The two things I have to do now are the decoder and then the CPU. Right, and I think I have to do the decoder first. These are some of the ones that either I completed or were completed for me. Right, let's start off with basic NAND, NOT, and exclusive OR gates. And there's a MUX, there's a 4-bit MUX, there's a 16-bit MUX. And there's a slightly different 4-way 16-bit MUX. I think it's the... Right, so I tab between these two tabs. You can see there's sort of, well, I don't have a pointer on this screen. Does that, I don't know, how do I get back? There we go, escape gets me back here. I'm just using up and down keys to go through this. Right, so have you met Ted? So Ted is nice in that he will add, once you do some work yourself, he'll add some extra stuff. So I didn't do all of the things that are under the completed directory there. So let's have a look at the things I have to do. The decoder. Does anybody want me to look at anything specific? Jordan, you were talking about a particular part of it, and I can't see Discord anymore because demux. Okay. So where's the demux gone? There's a demux there. Just the standard demux, yeah?
Yeah, that's correct.
Okay, so the demux element has one data input, one select input, and two data outputs. If the select input is 0, data is transferred to the first output. Otherwise, data is transferred to the second output. The value of the output, not taking the data bit value, is always 0. Okay, so you can see the truth table down the bottom there. If the select value is 0, then the input goes to output 1, and output 2 is always 0. If the select value is 1, then the input goes to output 2, and the output 1 value is always 0. So the idea is it's like a switch, either connecting input to output 1 if select is 0, or connecting input to output 2 if select is 1. So let's have a look at how I did it. Right, I think it starts out with the inputs and the outputs, and that's what it gives you. And then I decided that I needed 2 NOT gates and 2 AND gates. And I took the input and I created a not value for it, and I took the input and put it onto one of the inputs of one of the AND gates. I also took the select value and put that on the other input of that same AND gate. Okay, and then I took the output of that AND gate and I took it to output 2. So yeah, I can't really draw with this the way this is. So that's basically I've got one NOT gate and one AND gate connecting to output 2, and then I do virtually the same thing except flipped, right? So I'm putting the next time round, I'm taking the input and taking that straight into one of the inputs of the AND gate. That's the line fourth from the bottom. In goes to AND2.in1. Then I'm complementing the select by putting it into a NOT gate, the second NOT gate, and then I take the output of that second NOT gate and put it into the other input of the AND gate, and then I connect up the AND2 output to output 1, and that should let me do the demultiplexer. Let me just see if I can. Does that make sense? I can.
Yeah, it might. It's probably better than the way I did mine because I tried doing it with one knot.
Yeah, yeah. I think you need. No, it's not. Looks like it's grabbing the. I can't take a screenshot, unfortunately. But yeah, so it looks like it's. I think that's the way the demultiplexer should be put. I'm just going to see if I can reproduce that. Right, I've got, and I'm going to have to swap screens, go back into here. Sorry, I really should be better set up with to be able to share both screens, but that should do. Okay, so and this is what's happening, right? We've got our we've got let's make it a bit thinner. We've got in 1 and we've got in 2, and that's still causing problems, so maybe my and then we've got the select line, right? And the way I did it was I basically connected one of them, the NOT of the select, to one of the AND gates. So let's call this out, and it's going to be out 2, right? Because we want, when select is 1, we want the second input to be selected. Okay, so that's effectively, I think, what's happening. And I'm a bit confused, so let's go back to the, I'm just going to start up the game on the other screen and go back to the demux. I don't know whether that stops showing the Streamlabs output. Okay, let's go back to where we were. So I had oh, I'm sorry, it's a demux. I'm confusing myself. Right, so we only have one input and really confusing myself because I don't think I used the output of not one. That's interesting. It didn't complain about it. So basically, oh, I want my green. Right, so basically, I think that's all I need. I don't think, not one. I don't think I used the output of not one at all. So that's kind of interesting. So that's basically what I'm doing, right? The select is complemented one way or the other, and the input will go to the top output if select is 1, because it's the input is just going to be ANDed with 1, which is just going to be the input, and then the other output, if select is 0, this is going to be 1. So in that case, output 1 is selected. Okay. I'm just going to quit out of that so I can go back here. Okay, so Jordan, I hope that helps a little bit.
It works for me.
Yeah, good.
Yeah, so
good. Yeah, so I think I was overcomplicating it by having the two NOT gates. I only needed the one NOT gate there. I'm surprised the game didn't complain about that, but that's okay. Okay, I think I've talked to I didn't talk to Tommy, and I think, yeah, so Tommy, I've been just going through everybody and seeing where they are. How are you going with the labs and the game and that sort of thing?
Just about done with Lab 7. I just have to write the test bench and do the actual report, and started on the game this week and haven't touched Lab 8 yet.
Okay, that sounds good. Thank you. Okay, that's very good. So we're missing quite a few people today, and I didn't. Did I hear from Yasmin? Yasmin, how are you going? You're pretty far along as far as I can tell.
So I've finished Lab 6 and 7. I'm still working on the LEDs for Lab 8. I haven't had a chance to work on it. we don't plan on doing a project, and I don't have the game code, so I don't know when you would be able to get that to me by.
Yeah,
and
I'll try and get the missing game codes by Monday if I can. Okay, so feel free to ping me on Monday afternoon if you haven't heard before then.
Okay.
Okay. Okay. And I think that was everybody. Didn't hear from Jacob, I don't think. But yeah, so that was the other thing I was going to do is just have a quick look at the just have a quick look at how I've done the flashing of the LEDs. All right. And the thing to always remember is what I think I talked about last week, and that is that every well, there's two things, and actually the chat I had with Harvey was kind of interesting during the week. Two things to remember. Processes should only alter one signal, right? So that's one thing to remember. The other thing to remember is if you have a signal that needs to connect to an output, connect it to the output outside of a process. The issue is that changes in value inside the process only happen once the process is finished. Okay, so if you only connect your signals, your intermediate values, to an output inside the process, that value doesn't update until the process finishes. So what we were seeing with some of Harvey's code was that there was a delay between the 8-bit the 4-bit inputs to the adder compared with the output. The output was not showing the sum of the inputs. And the reason was because that connection from the output of the adder to the actual output, the intermediate value of the adder to the actual output, was being done out inside the process, and that was causing a delay between the calculation and the display. So let's in fact let's not do that one. I don't know whether that's the right one. That one. Let's try that one. Right, so here's the A version of Lab 6, and what was happening was those connections from the intermediate value sum to S out which is one of the outputs on the port statement, and Cout, which is the other output on the port statement. They were done inside the process. And because they were done inside the process, they weren't being updated until the process finished. So don't put them there. If you have those wired up, they should be wired up and happening all the time immediately. Remember, anything that is put outside the process happens all the time and at exactly the same time as everything else happening outside a process. Okay, so that's one piece. Let's have a look at the flashing of the lights. Close project I should have done. So okay, so again for the flashing, I made another variable called flash B, and so I made yet another process that changed the value of flash B based on the ball count. Right, the ball count's been done in a separate process, and here if the value of the ball counter goes above 3, then I set that flag flash underscore B. What happens when I set that flag flash underscore B? Well, then we go over here and this is another thing, but now I need a second intermediate variable. Well, two of them actually. I need another flag telling me that I'm in the middle of doing a flash. So if flash B equals 1, then I do that, and now I can do my flashes, and then I need a bit of a delay between each flash, so I need to turn the LEDs on and off. So I use a counter, and I wait for a count of 100, and then I set all the LEDs that's going to be setting them on. Then I wait for 200, I set them off, and I set them on again, and then I set them off. I set my counter to 0, and I'm no longer doing the flash and everything else. The reason,
so, flash B is a Boolean here.
Flash B is I think it's...
Or doing flash B is Boolean.
Flash
B is...
Yeah,
okay.
Exactly. So we can go up and see the definitions, right? So flash S and flash B are just static logic, and doing flash B and doing flash S are Booleans. That's why I've got the false versus 0. Okay? And the reason I need this doing flash B, I can't just use this flash B, is because I always set flash B to 0 if balls is less than or equal to 3, right? And remember, the ball counter is going to be reset after it goes bigger than 3. So this process do flash ball is immediately going to reset flash B to 0, so I can't depend on its value staying at 1. And that's okay. I just need another signal specific for this process, flash for ball, to keep remembering that I'm in the middle of flashing the LEDs for the balls. And just a reminder of what it looks like. Right, so there's my ball counter. Right, and it gets 2 flashes. And my strike counter gets 3 flashes. And let's have a look at the strike information. Right, the strike information is virtually the same, except I've got an extra time when I turn on the LEDs. The format is exactly the same. I do a, where is it gone? Do flash strike, there we go. So when my strikes go more than 2, I set the flash S variable, and then when I get a flash S variable of 1, I set my doing flash S flag to true, and if I'm doing flash S, then I increment my flash counter underscore S, and if it's 100 I turn the LEDs on. If it's 200, I turn them off. If it's 300, I turn them on again. 400 off, 500 on again, 600 off again, and then I'm done. So I clear the flag and I clear the counter.
How come you're using an if statement instead of like a while loop?
Instead of a while loop. How would a while... I'm not saying you're wrong. I just... How would a while loop achieve that?
Couldn't you just say flash LED, wait 100 seconds, then flash LED turn off, or no?
You can't... Weights like that are not synthesizable. You can use weights in the test bench, and that works perfectly okay for simulation. But weights usually aren't synthesizable. That is, they cannot be put onto the FPGA.
Got it.
So you've got to find some other way to delay or to wait between flashes. Okay.
Okay.
And just as a, again, I'm setting 2 separate variables, LEDs output S and LEDs output. Probably to keep with the naming convention, I should have called that LEDs output B. And then I wired up the those 2 variables, LEDs output and LEDs output S, outside of a process using a with select statement, and I keyed the with select statement off doing flash B. I could just as easily have keyed it off doing flash S and swapped around the conditions when true and when false. But that's I did the ball flash first, so that's why I've done it that way. And again, the reason I did this wiring up outside of the process statement is so I can not have any delay between what's happening on the output and what's happening in the process statement. Okay. Does anybody have any questions about any of that? Okay, if not, let's take a 10-minute break, and I'm not quite sure what I'm going to do afterwards. I might just have a quick run through the VHDL slides and see if there's something that we should talk about. But I think I've talked about most of the VHDL slides, and what I might start doing next week is a review of all of the course content, because I've pretty much covered what I want to cover. All I need you to do now is to finish those labs, finish the game, provided you've got a game key, and yeah.
Can you show me the doing flash process again?
Sure. So which one? This is the way the system sets the flash B flag, and I probably could have used a flash B as just Boolean rather than stood at logic. So it will always, again, to stop a register being formed, I need to set the value of flash B through all paths through the process, and so I set it to 0 if nothing else happens, but if the balls go greater than 3, then I set the flash B flag to 1. Like I said, could have been true, and that's all this process does. And then the flash for ball process is keyed off that flash B variable, and it sets its own internal variable doing flash B, so that I can keep the information that I am in the middle of flashing the LEDs for a ball, and the flash counter increments, and then I chose 100 as the flash duration, just because the timing I'm using on the slow clock, the div clock. Does that help, Yasmin?
Yes.
Okay. So let's, if there's no other questions, let's take a 10-minute break, and when we come back, I'll talk my way through some of the VHDL slides, just to probably with respect to Lab 7 and Lab, well, even Lab 6, 7 and 8, just so that we can hopefully help you get through those last 3 labs. So let's put that up, and I'll go on mute for about 10 minutes. Thank you. Okay, let's get back into the swing of things. So, where's it gone? There we go. I thought it might be good to think about what we've been doing, right? And I remember putting together these notes from a couple of years ago when I took this course, and I thought it might be good to think about the whole process again, right? So the issue is we have a design, and that's in VHDL, and we want to test it, and that's in a VHDL test bench. And then once we're satisfied ourselves that it works in simulation, so this is a simulation, then we want to deploy it to the board. And this is the hardware. I was talking to one of my former students last night, yesterday, and she's a software engineer, and the company she works for does embedded hardware, so they use FPGAs a little bit, and she was saying that she found a bug in the FPGA, and that the person who does the VHDL fixed it for her. And she tried to convince me that VHDL is not software, and I can sort of see that, but I think that L there for language is trying to tell me a little bit that the software is at least a little bit part of what we're doing here, right? It's very different because we've got to think about how it works in the hardware. For example, what I was talking to Harvey before about, right? We can use delays in the test bench, but over here, delays aren't synthesizable. So we need to, if we need a delay, like those flashes for the LED flashes for the ball counter or the strike counter, we need to do something else. It'd be lovely to be able to just say, okay, turn on, delay, turn off, delay, and put that in a little while loop. So maybe software is a little bit too specific, because if we were doing this in software, that's the way we'd do it, right? We'd be able to use the wait statement to give us a delay, and we'd all be happy. Ideally, when you're doing a test, you want to test exhaustively, right? Ideally, you want to test every input and generate every correct output. Unfortunately, sometimes that's not possible. And it's certainly true in software, but it is also a little bit true once we make larger FPGA devices. Right? I've forgotten how many I/O pins there are. Let me see if I can figure out how many I/O pins there are on our right, so there's our GitHub. And I don't know whether we have let's see if we can go to the hardware documents and the schematic. And I suppose we've got RS-232 ports, we've got an IR receiver, right? So we've got lots of outputs. I don't think I can zoom in there. Let me see if I can go to it on my desktop. That way I can zoom in on parts of it. Where's it? It's going to be in the Git, isn't it? CET466 hardware documents schematic diagram. Let's just make that, let's make it go full screen. That's probably not what I want. Okay, so there's lots of I/O on our FPGA chip. Some of them, well, let's just count it up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Let's turn that off. 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So there's, I don't know, 40 pins that we could deal with. And let me just sorry. yeah, so there's 40 pins, right? And let's say, just to make things simple, that every value was on every input was possible, right? So that means we've got 2 to the 40th possible combinations that we could use. Right, so that's a little large. So there's this idea, where have we got to? There's this idea, wonder why that's, I'm just going to close OneNote and open it up again. Let's see if it saves it appropriately. There's this idea called orthogonal arrays. No, it didn't save them. Okay, so these notes are just about the test bench, which you should all be intimately familiar with by now. And the right, you can test exhaustively. So the idea here is that you've got, in this example, 2 to the 11 possible combinations. I think somebody's not on mute and typing, so Anthony, can you mute please? I think your typing is coming through. Thank you. Okay, so the idea here is that instead of these factors are inputs, right? And let's make that a bit thinner. Right? And the idea is that instead of changing all of those 11 inputs from, in this case it'd be -1, right, 11 minus 1s, all the way up to 1, lots of 1s, right? That would, if we were doing it exhaustively, that would be 2 to the 11, which is 2048 tests. What this orthogonal array approach does is it takes a small number of those values and says, okay, I'm going to choose the 12 tests that I can do that are most different from each other. And what you should find is that going from one test to the other, there are several differences. There'll be similarities, right? So going from row 1 to row 2, there's those differences. Going from row 2 to row 3, there's these differences. Right, so there's 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5. So there's either, I think there's going to be either 5 or 6 differences between each row and every other row. And one way to think about that is, and I'm only going to do it sort of in 3 dimensions, if I can draw it all, which isn't my forte. Right? If you can think about, if we only had 3, actually if we right, if we had a cube right? One way we could do this is we could test at every intersection, right? So at each layer here, we would have 9 tests. I'm not going to draw the internal ones that are hidden, if you like. But every layer here, there's 9 tests. There's 9 here, there's 9 here, and there's 9 here. So there's a total of 27 exhaustive tests. But the idea with this approach is that we decide that we're only going to test the most different parts of the cube. So if we only test the most different parts of the cube, right, maybe, and there's going to be one at the back, right, maybe there's only 1, 2, 3, 4, 5, 6, 7, 8 okay, and orthogonal, one way to think of orthogonal is it's sort of like perpendicular, or at right angles, or cross purposes, or different from. That's the way I'm using the word orthogonal here. Right, so even that small change, going from 27 to 8 tests, can be useful, right? Certainly going from 2048 to 12 is very useful, right? That's over a factor of 100 less effort that we need to do if we're going to test our system. The thing we're trying to do with testing is we're trying to find bugs. We're trying to find defects. We're trying to find problems. And the reason why this approach often works is because you usually don't get a bug just in one place, right? If there was a bug right on that one there, then our orthogonal tests would miss it, right? Because we wouldn't be testing that particular value. Normally that's not the case. Normally bugs, defects happen in a larger region. So the idea is that actually the bug happens here with these 4 possible test points. And the thought is that one of them will be tested. So we'll figure out that there is a defect in our greatly reduced testing regime. And there's a nice page there about it. There's these sorts of matrices, these sorts of reductions are called Taguchi Matrices. And if you ever get into quality assurance, they're highly recommended in terms of reduction in testing effort for benefit of testing. And in fact, why don't we see if we can, I'll see if I can open that page up. Let's just go here. And where's it gone? There it is. that into a browser somewhere. There's a browser. And let me put that into the links part of no. For some reason it didn't copy. There we go. Right, so there's a variety of different sizes of these orthogonal arrays, and this page is actually about some I think it's using some software. This whole idea is in the area called design of experiments. Right, when you're putting together an experiment, you want to make sure that the experiment tests what you think it's testing. And sometimes you don't have the resources to test every possible combination. And this is a way to test a significant number of combinations without, and hopefully find issues. I actually used this, not for FPGA testing, but we had a little, we called it a gateway, a little piece of hardware, and it used a variety of techniques for connecting up to our, we used it to add internet connectivity to embedded devices, IoT type devices in the field, so that we could get access to them remotely. And there was a bug in the software on our gateway, and we couldn't figure out what the bug was. And we didn't even know quite how it was setting up. So what we did is we put together one of these Taguchi arrays, and because we had about 8 or 9 different combinations of how the device could be set up, or rather, actually, we had a lot more than that. But we got it down to having the test level was, we had 9 tests we could run, and each test had a significantly different configuration of the device from every other configuration. And the idea was that if we set the devices running and they blew up, then the different configurations would allow us to narrow down what the problem was. And it was like magic. We'd spent a couple of weeks trying to debug it, and reading code and manually testing. It didn't work. We set up this experiment with 9 of the devices set up in different configurations. We ran the experiment overnight. We expected we might have to run it for a week. Almost immediately, the next morning, some of the devices had already fallen over, and enough of them had fallen over that we narrowed down what the problem was, and we were able to fix it. But it's a useful technique to know about, if not to actually use. And I put those notes in there. Right, but that's the process, and that process is why I want you to include that information in your reports, right? The design, you need to talk about the VHDL code that you write. The test, you need to talk about how you test it, preferably with a VHDL test bench under simulation. And then deployment, you need to show that you can deploy the implementation to the FPGA and that it works on the FPGA hardware. Depending on the exactly what it is, that showing that the FPGA works is probably best shown using a video. And feel free to just upload either a video file to Blackboard if it'll fit. Otherwise, a YouTube video link is also fine. Any questions about that approach that I've been trying to get you to use for this course? Okay, if not, let's have a think about Vhdl nodes. We'll start right at the beginning again. Okay, so there's two main strands of this approach to designing digital hardware. There's VHDL and there's Verilog. And Quartus supports both languages. The only reason I chose VHDL is because that's the way Professor Zanella used to teach it, and there were a lot of notes available. I've since learnt that maybe Verilog might be better, but I did a bit of a check, and let's just see if I can find it quickly. I don't know, who is the true champ? I wanted actual data on the sizes, but it turns out I think there's some Google Trends, not a lot of difference. Amazon book listings, VHDL's more popular. Yeah, I don't think there's a lot of difference. I think one of them is more used in defense type applications. It looks like with the name Lockheed and Raytheon there, that looks like it's more defense oriented. Yeah, there's not a lot of difference that I could find in terms of use, in numbers of people using it. Okay, let's have a quick flip through and see if there's anything else that I don't know whether I talked about this, right? A lot of digital devices have what's called a GPIO, right? Which is, no, it's still blocking on me. So, general purpose I/O, input output, right? And what that means is, you know, you've got a chip you've got pins on the chip, right? And these pins can be configured for either input or output, which is kind of nice, but they're doing two different things. So oftentimes what happens on the inside here is something like this, right? Where you've got a buffer. If let's just say that the chip is on this side, right? So this is the chip. So here, if this one's selected, then that's an output. And if this one is selected, that's an input. And so you get to choose, and that's why Raspberry Pis and Arduinos and FPGAs all of those sorts of devices have GPIO. They allow you to reconfigure the device to use for pins to either be inputs or outputs. And the way they do it is something like that. That's sometimes called a transceiver, right? Transceiver means it can both transmit and receive depending on its configuration. And well, maybe we did talk about it, right? And one thing we haven't talked about is that we in our playing with quarters, we've seen values on the traces in model sim of U, 1 and 0, right? That means we don't know, it's unknown, and it usually comes out in red. Usually comes out in red in model sim. The other one that you can sometimes get is Z. And Z means that output has been disconnected by the chip, and it's it's gone into high impedance mode. And the reason you do that is because oftentimes you'll have these transceivers all sitting on the same bus. And you don't want more than one of them driving the bus at a time, because right, you can see if this one were driving the bus to 1 and this one were driving the bus to 0 and this one were driving the bus to 1, that could be a problem. So you turn the device off effectively and you get a high impedance input. And there's various Vhdl. I think this is the most interesting diagram as far as showing how things hang together. The stuff at the bottom, the device physics and the differential equations and Kirchhoff's voltage law and Kirchhoff's current law, we don't have to talk about that, right? We've already figured out what a resistor is, what an inductor is, what a capacitor is, maybe even what a transistor is, and we can put those things together into a discrete logic gate. And that's what so where certainly operating at this level. But then some of the things we're doing, right, the baseball counter, for example, is doing a state machine. And that state machine is a little bit more complicated than a gate, because now we need memory, we need to know what the state transitions are, and we need to know how to operate all of those. So most of what we're doing in VHDL is operating in this area. Maybe if we were doing some of the higher level protocols, we'd need to talk about algorithms or even specifications, right? So this is more about protocols. Yeah, that's really starting to bug me, the way that didn't used to do that. So I'm going to blame the operating system for now, because it's not lowering the frame rate didn't help. Okay, we've got that. I think we've talked about all of these things. Yeah. So remember the entity part of our VHDL description? That describes the interface. If you've ever done any systems engineering engineers aren't necessarily concerned with the details of how stuff is implemented, but they're very concerned with the interfaces between devices. And so the entity is very important from a system perspective. Obviously, you do want to implement everything appropriately, right? So that's what this is the implementation. And this is the interface. Okay. I'm just going to quickly go through. There's an example. So this way of doing things is a coding way of doing things, right? You type it out. The other way to do it is the logic diagram way of doing it. And I'll see if I can find that. We did data types. Right? The other way, let's just go back here. So the other way of doing it is in quarters. Is to, where's it going? The other way of doing it is in quarters, is to actually draw, logic gates. And they're the two different pieces. I think really you could do any of the labs using the logic, but I think the lab 7 is possibly the best lab suited for implementing it using the logic diagram. You can do it either way. There's no huge benefit from one or the other. It will depend on precisely which device you're most comfortable with, and what the actual problem is you're trying to solve. Okay. I don't have anything much more to say. I would prefer to be better prepared to summarize the course, so I'm going to push that off until next week. Does anybody have any particular problems that they want me to help with? I want you to get labs 6, 7 and 8 done. I'm happy to look at more of the game if that's what you want to do. But if not, let's call it quits today and get those labs done. I'll hang around for the next couple of hours if anybody needs me. But I don't have anything specific to talk about. I did find that that testing stuff with the orthogonal arrays kind of interesting, so I did want to mention that. But other than that, I don't have anything new that I wanted to talk about today.
Are the bookings available for the final exam?
Good question. I think so. Let's have a look. Right, so there's CET466 final, and you will see there's nothing in November. I currently have Wednesdays and Thursdays open up until the 19th.
Was this link emailed to us?
It's the same link that's always been for bookings.
Okay.
So if you go into Blackboard, and I don't change the link, right? So
that 9th we have capstone presentations though, right? December 9th.
Yeah, probably. That's probably not the best. I should probably block out my calendar for that. Good point. Yeah, let me block out my calendar for that so that closes up those. So it's the December 9th. Yeah. Let me get the right calendar. There we go. Okay, that'll take a while to update, but I've blocked out the time on my calendar for, yeah, but where that is, course info and tools for remote work, I think, maybe? Maybe I didn't share it. Didn't I share it? That's odd.
I'm not sure you did, yeah.
So, Professor, you have
Yeah, 'cause
a
for the
section for the
midterm-
oral and assessment, but it doesn't link to the booking at all.
You shared it in links. In
Right.
Discord.
Oh, did I in Discord? Okay, let me put it in tools for remote working as well. Yeah, I thought I did, but obviously not. That's the trouble with having too many places. So okay, let's leave that there, and I'll move that up to the top of the list. Okay, so that's in Blackboard, and it should be in one of the links in Discord as well. Let's have a look. There's lots of links in Discord. Let me see if I can pin it. If I can find it, that's the next question. And what's the CCSU 6? See if I can find that. There we go. That's in discussion. There's the links one, and let me see if I can pin that. Okay, so if you go to links now, you should see that link pinned. Right, so where are we? Maybe? Right, so here's Discord, here's links, here's the pin, and there's the link that should take you to the my bookings page. Okay. Any other questions? Okay. So what I might try and do, I'm not guaranteed to do it, but what I might try and do is I might try and get a draft of the final exam done for next week, and that way I can focus your minds on the review of the course. I'm not going to answer any of the questions on the exam directly in what I talk about, but I'll structure it. I'll structure the review so that you understand where I'm coming from. I'm also happy to spend more time on the game, and between now and next week I'll spend some time finishing the game, or trying to finish the game, just so that I know some of the foibles that you might come across. Okay?
I don't know if this is really like an absolute question you can answer, but like, how complicated did you want the projects to be to like submit?
I want them. I want them reasonably complicated, and I know that's not an answer. The sorts of, let's see if I can go over here. Right, so whenever you compile a
so like, how much more complicated than the baseball counter, I guess, for reference?
If you could make it as complicated as the full baseball counter, including the with the piece I haven't done, which is the undo, that would be perfectly acceptable.
Okay, that answers my question then.
Yeah?
Yep.
So the thing to look at, and I'll wait till for this to compile, the thing to look at are the total logic elements and the total registers. That's the number that you should think about hitting if you want a reasonable project, right? So this is saying it's about 390. So about 390 is the sort of project. I don't want it to be, you know, I'm just going to add VHDL code until I hit 390. That doesn't make any sense. But if it's a logical idea, and it gets up to about the 390 logical elements and 239 registers, and uses a few of the pins, that would be good. Okay?
Sounds good.
I have a question about the game. Do you know about how long, how many hours are put into it? Because I think I'm around like 7 hours. I'm just trying to figure out how long this game is.
That's a good point. I really haven't tracked my own time on the game. What I might do is I'll spend some time over the next week on it, and I will look at how much time I spend on it, and that should give you some sort of a go. My guess is probably you've got another I'd say 10 to 12 hours left, based on if you're just on the demultiplexer. So there's a significant, because some of the next pieces are a little complicated. Actually, they're complicated, but they're when Professor Broderick and I had a go at the game, and we both overthought some of the next pieces. I haven't done the decoder yet, but I've forgotten the piece that was before the decoder. But it's yeah, they're complex, but my advice is to not overthink how they're done. I know that's not really an answer, but my guess is, Jordan, that another 12 hours is probably what you'll need to finish it up.
And you can't change the names of the inputs and the outputs, right, to shorten them?
No, I don't believe so.
Okay, because I tried doing something like that, and yeah, I don't think it liked it.
Yeah, that's probably true. I think you've got to take the inputs and output names that it gives you and then work with them.
Couldn't you use like a signal and create a signal and then assign that signal to that output?
Oh, maybe. I don't know. Yeah, maybe. I don't know. I don't know whether I needed to do that. I can't remember off the top of my head.
Well, I'm just saying because he said he wanted to shorten it. So if you wanted to use a shorter version, you could say signal A.
Right, right, and rename it. Yeah, exactly. I'm just not sure how much of that functionality, that VHDL functionality, is available in the game. That's all. Okay. Get Lab 6 done if you haven't already. Get Lab 7 done. Get Lab 8 done. Finish the game if you can. I will try and get those 3 people who haven't got game keys by Monday. If not, I'll figure out how to get you game keys. And let's leave it there for today.
Have a good weekend, Professor.
Okay, thank you. As I said, I'll be online for the next little while, so feel free to just ping me here or in the discussions. And